Welcome to Math TV with Professor V. This is video lecture number 36 for intermediate algebra on expressions containing several radical terms. So before we talk about how to simplify radicals using addition or subtraction, I want you to think back to when you first started combining like terms. So say you were to simplify 3x plus 5x. Those are like terms because notice the variable expression in both of these terms is the same and both variables are raised to the same power. So we can go ahead, combine these like terms into 8x, right? We don't touch the x, we don't change the variable portion, we just add the coefficients, 3 plus 5. Similarly, if you have like radicals, I'll define that in just a second, something like 3 rad 7 plus 5 rad 7, that can be simplified into 8 radical 7. So think of the radical portion like your variable portion. That doesn't change. All that you're doing is combining or adding the coefficients using the operation that's there, in this case addition. However, if you had something like 2x plus 3y, could you add those two terms together? Well, no, those aren't like terms because the variable portion doesn't match up, right? One of them has an x, one has a y. And similarly, if you have something like what's written here, 2 radical 3 plus 3 radical 2, this cannot be simplified further. Okay, so now we're going to define what like radicals are, because we're going to be referring to that throughout this lesson. So like radicals are radicals that have the same index and the same radicand. So if you have the nth root of a, remember n is your index, so that has to match, and then a is the radicand, the stuff underneath the radical. If those are both the same on multiple terms, then they can be combined, okay? So let's look at some examples here so you can get comfortable doing this. Example A, we're just adding or subtracting, whatever's appropriate. So we have negative 4 radical 3 plus 9 radical 3. These are like radicals because we have the square root of 3 in both of these. So we're going to go ahead and just combine the coefficients. Negative 4 plus 9, that's positive 5. And then just rewrite radical 3. Leave it alone. Don't touch it. Okay? Very good. Not bad. Let's move on to example B. Here we've got 4 terms. If I look here, 16 radical 3xy, is there another term that has the same index and same radicand? So another square root of 3xy? Yeah, right here. So I can combine those two by performing the subtraction with the coefficients, 16 minus 7. So that's going to be 9. And then keep the radical part the same, radical 3xy. And then who else is there? 5 rad 7x. Well, here's a 9 rad 7x. So you just focus on the coefficients. 5 plus 9, that's 14. Radical 7x. And then that's it. You can do no more. These two terms are not like radicals, so you can't combine them. Where'd that arrow come from? Okay, lovely. Let's go to example C. 7 radical 2 plus radical 8. Now you might be saying, these aren't like radicals. But wait a second. Radical 8 is not completely simplified. So let's try simplifying first and then see what unfolds. 7 rad 2, yeah, that's as simplified as things can get. But remember, rad 8 is 4 times 2, so that'll simplify to 2 rad 2. And now we do have like radicals. Rad 2, rad 2. So I'm just going to go ahead and combine coefficients, and we have 9 rad 2. Okay, how you doing? We got one more like this, cube root of 27 plus 5 times the cube root of 8. You might be saying, no, these are not like radicals. But again, I'm going to remind you, let's simplify first. Don't we know the cube root of 27? That's just 3, right? Oh my goodness, yeah, it sure was. And then 5 times cube root of 8, that's 5 times, you know the cube root of 8? What number multiplied by itself 3 times gives you 8? Yeah, it's 2. So, oh my goodness, this is just 3 plus 5 times 2. We could have done this one back in kindergarten. So this is 3 plus 10, 13. Probably not kindergarten, but you know what I'm saying. Okay. Sometimes these problems look worse than they are when you just break them down. So now we're pretty much experts on addition and subtraction with radicals. Let's move on to multiplication. So say you have something like 8 rad 3 times 4 rad 2. Again, I'm going to go back to when we were just working with variables so you can see how the rules work. So say you have something like 8x times 4y. What would you do? You would multiply the coefficients, right? 8 times 4, so that would be 32. And then x times y, you would just put them together like that. So similarly with radicals, whatever the coefficients are, whatever numbers are sitting outside of the radical, you're going to multiply those by each other. So 8 times 4, that's 32. And then you still have square root of 3 times square root of 2. And since rad 3, rad 2, those are both positive, and in a couple of videos ago we went over multiplying radicals, we know that we can combine them under the same radical and then multiply 3 and 2 together. So basically, all the numbers that are outside the radical get multiplied by each other, and then everything underneath the radical, they get multiplied by each other and they stay there. Think of it like they're very cliquish. If you're outside the radical, you only hang out with other people outside the radical. If you're underneath, you only stay with people who are underneath, okay? Good. So let's practice now. And we're going to bust out our distributive properties, foiling, all that good stuff that maybe you haven't thought about in a while, because we're ready to make this fancy. So simplify completely. I'm going to distribute, okay? So rad 3 times rad 7, that's going to be rad 21, plus rad 3 times rad 6 is rad 18. Good. Before you start celebrating and get ready to box this answer, remember, you have to simplify completely, okay? So rad 21, do any perfect squares go into 21? No, there's 4, 16, those don't go into it. Oh, 9, what about 9? But no. And then 25 is bigger than 21, so that's simplified. 18 though, 18 is 9 times 2, so this is 3 rad 2. And then those are not like radicals, so I'm done at this point, okay? Very good. Let's move to the next example. Ever so barely trickier. 3 rad 7 times 2 rad 7 plus 4 rad 5. So we're going to distribute, okay? 3 rad 7 times 2 rad 7. So you're going to do 3 times 2, that's 6. Rad 7 times rad 7. Remember when we were rationalizing denominators? That would just give us 7. If you forgot why, it's because you have rad 49, which simplifies to 7, right? So 3 rad 7 times 2 rad 7 is just 6 times 7. Plus, now I'm going to multiply 3 rad 7 by 4 rad 5. So again, very cliquish. 3 only hangs out with 4. So 3 times 4, that's 12. And then rad 7 is only going to hang out with rad 5 in their exclusive club under the radical. 7 times 5, 35. Yeah. And then that's it. So 6 times 7, 42, plus 12 rad 35. And that's it. Box it. Don't do something bizarro like, I don't even want to say it and put the idea in your head, but I have to address it in case you were thinking. Like, I've seen some students make this 54 rad 35. Can you believe it? I can't even look at it. That's so disgusting. I'm erasing it. So think of it like it's 42 plus 12x, right? 42 doesn't have a radical, so it can't be combined with the other expression that does have a radical. Okay. Hopefully that didn't hurt your eyes too much. You can still see. Let's look at example C. We have to FOIL, yeah? This is exciting. Do you remember how to FOIL? First, outer, inner, last. Okay, first product. Rad 2 times rad 3. That's just rad 6. Minus. Let me erase so you see what I'm talking about in the moment. Outer would be rad 2 times negative 2 rad 2. Okay. Negative rad 2 times 2 rad 2. Well, it doesn't matter which one's negative. Let's write it out here. Rad 2 times 2 rad 2. You have 2 times rad 2 times 2. So this is 2 times 2, which is 4. Okay, so this is going to be minus 4. Inner product right here, plus 5 rad 3 times rad 3. Well, rad 3 times rad 3 is just 3. 5 times 3, that's 15. And then last product minus 5 times 2 is 10. Rad 3 times rad 2, rad 6. Okay? And then let's see, can we clean up further? Yes. So negative 4 plus 15. Those don't have any radicals on them, so I can combine them. 15 minus 4, that's 11. And then this rad 6 in the front, the coefficient is a 1, right? We just don't write it. So 1 rad 6, I can combine with negative 10 rad 6, and now I have negative 9 rad 6. All right, that one's done. Very good. 5 minus rad 2 squared. Do you remember how to square a binomial? So when you have a minus b squared, you end up with a squared minus 2ab plus b squared. So let's try that here. A squared would be 5 squared minus 2ab. Let me write it. This is a, this is b. So 2ab would be 2 times 5 times rad 2 plus b squared, rad 2 squared. Yeah? Okay, good. So this is 25 minus 10 rad 2 plus rad 2 squared is just 2. And what can I combine? Just the 25 and the 2. So now we have 27 minus 10 rad 2. Oh, that one was cute, huh? Lovely. Let's try another one. Why don't you guys pause the video, give this one a go. The only difference, since we have addition here, when we square this quantity, a plus b squared, you get a squared plus 2ab plus b squared. So remember, whatever sign is between a and b, that matches the coefficient of 2ab. B squared is always positive. Okay? All right, did you pause the video and give it a go? I hope so. So here we go. We have a squared, so that's 4 rad 5 squared plus 2ab plus b squared. So 4 rad 5 squared, be careful. You square the 4, so it's going to be 16. You square the rad 5, now it's 5. These still stay multiplied by each other. Plus 2 times 4 times 5, those are all outside the radical, so that's going to be 8 times 5, so that's 40. And then you still have a rad 5. It's underneath the radical. It has nothing to do with anybody else. Very conceited under its little radical club. Plus 5 squared, that's 25. Okay, and then we can combine 16 times 5, that's 80. 80 plus 25, 105. So we've got 105 plus 40 rad 5. Ooh, 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 I love it. I love it so much. Okay. Let us look at another example. This time, if you'll notice, we're multiplying conjugate pairs. Yeah? Do you remember our rule when we multiply conjugate pairs? A minus b times a plus b, we end up with a difference of squares. A squared minus b squared. Okay, so let's try that out here. So I'll do it the long way first, and then you'll see why a squared minus b squared is just so beautiful in this scenario. So let's FOIL it. 3 times 3, that's 9, plus 3 rad 5, minus, here's the inner product. I don't put rad 5 times 3, you put the 3 in the front, so minus 3 rad 5. And then last product, minus rad 5 times rad 5 is just 5, yeah? And then see, no point in FOILing because this cancels. And you just end up with 9 minus 5, which is 4. And you could have gotten 9 minus 5 because a was 3, so a squared is 9. B is rad 5, so rad 5 squared is just 5. Yeah? Okay, so based on that, I think you guys can do G just in your head. See if you can do it right now. Don't write a thing down. Take about 10 seconds. Do you know what the answer to G is? It's 1, right? Did you get that? Okay, again, we have conjugate pairs, so when we multiply it out, we're going to get a difference of squares. So we're going to have rad 12 times rad 12, that's 12, minus rad 11 times rad 11, that's 11. So this is 1. Ooh, sneaky little problem, huh? But so cute. Now, something I want you to notice is that when you have an expression with a radical that involves addition or subtraction, and if you multiply by its conjugate, the result is a rational number. Notice for F and G, our final answer didn't have any radicals in them. They were rational numbers, meaning they could be written as a ratio of 2 integers. This is important for the idea that's coming up next. In the previous lesson, we rationalized denominators, such as 3 over rad 28 or 5 over the cube root of 4x. If you want to go back to the previous lesson, you can review how we did that. But I just want to point out, maybe we'll just look at this one here, like 3 over rad 28, just to jog your memory. First, you'd simplify that rad 28, right? So rad 28, that's 4 times 7, so this is 2 rad 7. And then remember, we don't want to have square roots in the denominator. So to get rid of them, we actually just multiply by whatever we're trying to get rid of. So rad 7, you need to go away. So I'm going to put another rad 7 in the numerator. That way we're just multiplying by 1. And then now we can simplify. So we have 3 rad 7 up here. In the denominator, I'm going to have 2 times 7, since rad 7 times rad 7 is just 7. And then we're done. This is 3 rad 7 over 14. Yeah? Okay, and then we did something similar with cube roots. But what if we had a little something like 1 over 3 plus rad 7? So there's addition going on down there. Would our method work? So what method did we have again? We multiplied by the radical that we were trying to get rid of. So you might be like, oh, let's just multiply by rad 7. That sounds good. Is it though? So you've got rad 7 in the numerator. That's not a problem. You don't care what happens up there. But look, when you distribute here, you're going to have 3 rad 7 plus rad 7 times rad 7 is 7. Oh no, it just moved the problem to the other term in the denominator. I still have a radical. So that's not the way to go. I'm so sorry. We have to do something different when there's addition or subtraction in the denominator. And what do? We multiply by the conjugate, okay? So if you have 1 over 3 plus rad 7, you're going to multiply numerator and denominator by 3 minus rad 7. Why? Because like we saw a few minutes ago, we're going to end up with the difference of squares in the denominator, which will make all the radicals go away. So 3 times 3, that's going to be 9, minus rad 7 times rad 7 is 7. Now the problem is fixed. See how we have no radicals in the denominator? And we don't stress about the numerator. 3 minus rad 7 times 1 is just 3 minus rad 7. So then we're left with 3 minus rad 7 over 2. And you could leave it like that. Okay, so When you're asked to rationalize the denominator and you notice that there's addition or subtraction going on downstairs in the denominator, you got to bust out the conjugate instead, okay? So here we go. I got 3 little examples for you. 3 over 2 minus rad 5. So take a second, think, what would we need to multiply by to rationalize the denominator here? What would the conjugate of the denominator be? Did you figure it out? It's 2 plus rad 5. Yeah, is that what you were saying? 2 plus rad 5. Okay, so let's take care of the denominator first. 2 times 2, right? We're just going to get a difference of squares. So you don't need to sit there and FOIL. 2 times 2, that's 4. Minus rad 5 times rad 5, that's 5. And then in the numerator, you can just distribute as well. Okay, so 3 times 2, that's going to be 6, plus 3 rad 5. Okay, in the numerator, you can't combine, right? Those aren't like radicals, so you're just going to have 6 plus 3 rad 5 over negative 1. And it's not simplified to leave that negative out in the denominator like that. So you've got a couple options, okay? You can either put it outside like this, but that can also look confusing. So remember, it means the same thing as applying a negative to the whole thing. And I'm not going to put the over 1 anymore because it's useless, right? Over 1 is just itself. You could leave it like that, or you could distribute the negative. Negative 6 minus 3 rad 5. Let's do that, okay? Good. A is done. Let's hop on over to B. This one is a little more spicy. We've got 5 plus rad 3 over 4 minus rad 3. Now remember, when deciding what to multiply by, only look at the denominator because we're rationalizing the denominator. So what's the conjugate of 4 minus rad 3? 4 plus rad 3. Yes, very good. And then you have to multiply by the same thing in the numerator. That way you're just really multiplying by 1, right? If you have the same thing in the top and bottom. Okay. So let's see. The numerator, it will be just a bit of a mess, yes, because we do have to full on FOIL. Look at us. Okay, so 5 times 4, 20, plus 5 rad 3, plus inner product 4 rad 3, plus last product, rad 3 times rad 3 is 3. Love it. Denominator. This should be your favorite part because it's just a difference of squares. You can just relax. 4 squared, 16. Minus rad 3 squared, 3. Ooh, not so bad, right? Okay. Then let's see, what can we combine in the numerator? 20 plus 3, right? I can combine those. Those are like terms. So 23 plus, these guys are like radicals, 9 rad 3 over 16 minus 3 is 13. Okay, that's that one. You feeling good? Got one more for you. Yes. 4 over 3 plus rad 5. Okay, so we're going to multiply by 3 minus rad 5. 3 minus rad 5. So let's see here. Denominator's going to be, that's the best part, 3 times 3 is 9. Minus rad 5 times rad 5 is 5. Okay. Distributing the 4 across the numerator, that's 12 minus 4 rad 5. And then let's see what we got now. So 12 minus 4 rad 5 over 9 minus 5 is 4. Now there's 2 ways to simplify this. One is dangerous. I don't even want to speak of it because if you're watching this video, probably at the beginning of your math journey or you need a refresher. So I don't want to show you shortcuts that might give you bad sloppy habits. So when you're going to simplify here, because you might notice like, oh, can't we cancel? Yeah, but you got to cancel from everybody in the numerator. You can't just willy-nilly start slashing out 4s. So factor the numerator, okay? What can I take out from both these terms? A 4. And then you have 3 minus rad 5. Actually, did you notice? We're back at this step, but whatever, it's fine. We didn't know this was going to happen. This is the natural way to do things. over 4. Then you can cancel the 4 safely, and you have 3 minus rad 5. The reason I tell you to factor first is because you know what frightening thing occurs often? I see students and they'll just cancel this one because it's so obvious, and then they forget to cancel from the 12, and then they'll put something like 12 minus rad 5, you know. When you're a little bit more mature, maybe you'll remember that you got to cancel from everybody and make this a 3, but you know, you're taking a little bit of a risk there. Know yourself. Are you a careless sort of mathematician? Then I wouldn't do it that way. You know what I'm saying? Your other option too, which can be quite nice, sometimes you can split the denominator, right? This is 12 over 4 minus 4 rad 5 over 4. And then you can go bam, bam. It is satisfying. I will give you that. So then you have 3 minus rad 5. Okay? But either way, just make sure when you're canceling out that you do it in a way that is equitable. Everybody in the numerator has to be involved. Okay? Good. And then one other idea is working with products or quotients that have radical terms with different indices. So in this case, it's often helpful to convert to exponential notation. So rewriting without the radicals and writing things as rational exponents. Clean it up and then go back to radical notation. It sounds way worse than it is. I'll show you right now what to do. Okay. So here we have cube root of x squared times 6th root of x to the 5th. So we can't combine them as is because notice the indices are not the same. So what I'm going to do is rewrite it. Instead of cube root of x squared, that's the same as x to the 2/3, which we went over in previous videos, times 6th root of x to the 5th, that's x to the 5/6. Yes? And then now think back to our properties of exponents. We add these two together when we're simplifying. So this is going to be x raised to the 2/3 plus 5/6. Yes. 2/3, we got to get a common denominator. That's 4 over 6 plus 5 over 6. So this is x to the 9 over 6, which reduces. That's x to the 3/2. Okay. So since this was originally written with radicals, I'm going to go back to that. And if we have x to the 3/2, that's the square root. Remember, we don't put the 2, but that's what it means, of x cubed. And that's not completely simplified because x cubed, remember this is rad x squared times x. They didn't say whether I should assume variables are positive, but I'm just going to go ahead and do it. So rad x squared, that's just going to be x, and then we have rad x. Okay, good. That's your final answer. One more. 5th root of x cubed y to the 4th over square root of xy. So in the numerator, we're going to have x cubed y to the 4th. 5th root means it's to the 1/5. And then square root of xy is xy to the 1/2. And then remember, this exponent distributes. Yes. So we've got x to the 3/5, y to the 4/5 over x to the 1/2, y to the 1/2. And when we have division, our rules of exponents tell us to subtract top minus bottom. So we'll have x to the 3/5 minus 1/2 and y to the 4/5 minus 1/2. Now it's fraction time. Common denominator's 10. So x to the 6 over 10 minus 5 over 10 times y to the 8 over 10 minus 5 over 10. I know it's ugly. 1 second. And then this is going to be x to the 1/10, y to the 3/10. So notice they both have denominator 10. That means that's going to be the index when I go back to radical notation. So 10, and then x is to the 1st and y is cubed. Bada bing, bada boom. If you remember how to do that in your next math classes, you will be ahead of your peers, let me tell you. Even my sweet calculus students don't remember all this. It's one of those things. If you don't use it on the regular, perhaps you forget. I recommend you all start tutoring as a side gig and a way to personally review. Okay, that concludes the lesson. If you enjoyed it, give it a thumbs up. Subscribe to my YouTube channel if you haven't already. Hit that notification bell. That way you're notified every time I upload, which is pretty much daily lately. And I'm coming on camera more, which people seem to like. So working on that. And if you guys have any video requests, you can always join my Patreon and get access to exclusive on-demand content. Stay tuned, guys. I'll see you soon.